So here is a run through of exercise 5 in the Boston Fingerprints project. So let's say that we want to consider the different manufacturing techniques used in the pottery found at the Parker Harris pottery site and the Three Cranes Tavern. So in this exercise we'll be combining both visual and metric approaches to consider the different surface treatments used on the potsherds from the dataset. So we'll be taking simple measurements from the 3D models in CouldCompare, and we'll work with multiple meshes in the same project using multiple 3D viewports in tile mode, and we'll employ all the skills you've developed in exercises 1 through 4 and combine visual and metric analyses to interpret the 3D data to learn more about how the pottery found at these sites was actually manufactured. So first, we'll want to start by importing the STL files for TC23 and merge the meshes as you've done before. So it'll take a bit of time for those to load in, but then once they do, merge your meshes. And I tend to get rid of the originals just to keep it clean. Rename your 3D model just to keep track of it all. So you might notice that unlike some of the other sherds you viewed before, the surface of this vessel appears to have been brushed with some sort of tool. Let me change the color and then might come through a bit easier. So it seems to have been brushed because unlike the other potsherds we've looked at where the striations go consistently across, you can see like about here there's kind of a stroke that goes in a different direction and then kind of gets truncated there, and then another one that goes at another angle there. So there seems to be some sort of different surface treatment going on for this vessel in particular. So we don't need the whole pot sherd to analyze these. So find a spot where you can get a good brush stroke. This one is pretty safe here, and then use the segment tool to kind of isolate that area. So you want a mostly complete brush stroke in here, but you don't want to get something that's too... You want something that's relatively flat just because of the different analyses that we're going to be doing later on, but this should be good for now because you can see we have that basically complete brush stroke there. So we'll be happy with that bit. Turn off the remaining part. Right. So here we're going to take some point-to-point measurements to kind of quantify what kind of brush or tool might have been used here. So point-to-point measurements are another one of those functions in CouldCompare that only really work with the mesh's vertices, so the underlying point cloud. So here we'll turn our vertices on, like you did in step 4 of exercise 4, and we'll highlight the vertices layer, and then select the point picker tool up above. So this new toolbar has popped up in the top right corner. So to measure between points, you'll want to select the second one here. If there's only 2 you want to go between, and then click in 2 places on the 3D model to measure the length of a feature. So here we have what I perceive as the end of that. If this pops up, just go ahead and click yes, and then it seems to end somewhere around here. So you can see the distance between these 2 points is 12.25. And so because this is a measurement that goes, it's like a straight line, because this is a straight line measurement, you'll want to make sure that this is not cutting through your 3D model too badly, because otherwise that's not a really accurate measurement. So it is a little bit here. You can see there's a bit of space there, but for our purposes at the moment, it's not bad. So yes, it's roughly 12 millimeters long. So because this seems to kind of be truncated on either side by other brush strokes and things, what might be more useful is measuring the actual width of the tool. So this is the tough part, figuring out where exactly you'll want those points. And so you might need to move the 3D model around a bit just so you can get a sense of where the trails are leading, and you might need to do it a couple of times, but if I were to say that this is roughly the width of the brush stroke there, and roughly around 4 millimeters wide, you could test this on a couple other spots on the pot, but if the measurements vary like ever so slightly, it might be that this actually is a brush, and you can imagine that the brush might not maintain the same width consistently as it's being used. So things like that you need to take into account as well. Okay, let's import some more potsherds to see how their surface treatment differs. So in this one, I'm going to choose to import pH 21. Right, so you import your pH 21, which has some really different decoration and surface treatment. It's actually quite smooth compared to the brush strokes of TC23. And so I think we can already tell that like these two defined bands were created with a different tool than TC23's tool, so we'll ignore TC23 for the moment. But perhaps we want to measure some of these bands and see if there's a possibility that a tool was used to make these indentations, these bands going around. So again, we'll have the vertices selected for this. You select the point picker tool, and you use the second option to use these measurements. So roughly 7 millimeters, pretty close anyway. Obviously this is not the most accurate method of measuring, though as long as you're careful about it, it's pretty close. And so here it's a bit difficult to decide where this should be measured from. There, I was a little off on my measurement. So you can see that these are actually quite similar in terms of width. They vary a bit depending on where you get your points in, but it seems as though 6.8, 6.9 is the rough width of those bands. Obviously you want it as straight as possible. So it's the most accurate measurement. But so it is interesting, and it seems as though those two trailed bands across pH 21 could have been made by the same tool. And so what function that might have served, or what importance that sort of decoration would have had to the form of the overall vessel, not sure, but there you are. So now you might want to compare the two potsherds side by side in real time. It's useful because they'll be at the same scale in the same 3D space. So if we eventually, when we separate these out into different 3D spaces, they'll be at different scales depending on how you zoom in and out. But if we want to compare them side by side as if you had the two potsherds side by side, let's do that. So we'll enable TC23 again. So because we quite like how, I quite like how pH 21 is oriented at the moment, we'll choose to translate and rotate TC23. So the translate rotate tool is just here next to the segment tool. And so now you can start rotating this freely. And so you use the left mouse button, click and hold to rotate, and then use the right click button on your mouse to pan or translate in this case. So let's say we're happy with that. We'll see if we are. So they are almost on the same plane, almost. If we want to make comparisons between the two, we'll want them roughly on the same plane, just so that if you make visual comparisons between things, if something's closer in terms of perspective, it'll throw off your perception of things. There we are, getting there. This is a bit more finicky here. Good, so we have them side by side. I'm going to turn off their vertices because that's always a little bit distracting for me. Right, so now you might be able to look at them side by side and be like, okay, this is quite different in terms of surface treatment compared to this other one. So now if you want to allocate these two different 3D views, remember you can just do this with the drop-down menu. You just have to click New so that there's another place to put them. And let's say we want to put TC23 in 3D view 2. And there it is. And then if you want to use, look at them side by side, you can either choose tile, which will roughly break them up so that they fit the screen equally, although it tends to put them in the opposite order of what you would think they would do. And so here you are. And as I said, these are now at different scales. You can see the scale changing. This would be more accurate in terms of being at the same scale, because you can see the scale bar is the same in the bottom right hand corner.